Hey everybody, what's going on? This is Caleb with devslopes.com, and in this video we're going to continue talking about protocols and delegates, except this time we're going to see how they can be useful in classes and structures, specifically classes, but the same principles apply to structures as well. So we're going to remain in the same playground as the last video, but I'm going to make some space just so that it's like we're using a new one. Go ahead, and we're going to actually begin by creating kind of a quiz generator that can generate a random question. And we're going to write a class for a question. Okay, we're going to give it a few properties, an initializer, and then we're going to create some enums for question types and answer types. So let's go ahead and let's just begin with our class for question. Go ahead and type, class question, and then we need some properties here. We need a question type. So go ahead and type var type, and that's going to be of type question type, which we have not yet created. We will below in just a moment. Go ahead and type var query of type string and var answer. Okay, those are the things that every question should have. Below, go ahead and give it an initializer and pass in a type of question type, a query of type string, and an answer of type string as well. Go ahead and set them up by typing self.type equals type. Of course, that's not going to work yet because we haven't created the question type enum. Self.query equals query. And self.answer equals answer. Now, it's going to yell at us until we create our question type enum. So let's do that now. Okay, so below our class, type enum question type. Okay, and it's going to be of type string because each question should have a string value, right? That's where the words of the question will come. And we're going to create 4 different question types here. Go ahead and type case true false, case multiple choice, oops, that's with a C, case short answer, and case essay. Okay, 4 different kinds of questions. And let's go ahead and let's give these each an explicit value just for this example by typing equals and a string here. And we're going to just say, is the sky blue? There's my true false question. Or wait, that's not a question. How about the sky is blue? True or false? Multiple choice, we're going to give some options here. Who is the ugliest beetle? Well, I guess colon, John, Paul, George, or Ringo. I have my opinion, but I'm not going to say it. Short answer will be, what is the capital of Oregon? My home state. And for the essay, let's give a nice, really easy question here. How about in 50 words, explain molecular fusion. Easy. Okay, great. So there's our question types. Next, we're going to need answer types as well. So we're going to just create static answers for these questions. And let's do that by creating an almost identical enumeration called answer type. So go ahead and type enum answer type of type string. And we're going to create the same cases. Case true false, case multiple choice, case short answer, and case essay. Now we're going to give these explicit values as well. The sky is blue is going to be true. Okay. Multiple choice, we're going to say Sergeant Pepper. We're going to obviously get that wrong. We're going to say the short answer is Salem. If you knew that, bonus points for you. Ding, ding. And the essay will say molecular fusion happens when a daddy molecule and a mommy molecule love each other very much. That's not really how it works, but that's just my thought on how it works. Anyway, so we have 4 question types, 4 answer types. They have explicit values, and we can initialize a question, okay, of type question. So pretty cool. Now what we're going to do is we're going to create a protocol, and we're going to give it a method and it's going to basically be a blueprint for our question generator. Let's say we're building a quiz app, and of course, this data would probably come in from an API, pulling random questions. But we need to basically set up a blueprint that's going to allow us to generate questions when we need to. So go ahead and type protocol question generator. And inside our protocol, we're going to declare a method. Okay, so go ahead and type func generate random question. And we're going to actually have this return a question to us. But remember, we don't have any kind of implementation inside this protocol. So we don't need to put curly brackets. We don't need to write any code. The protocol is just the blueprint. So basically, this helps us to include what we actually need and to include the kinds of functions that are required for a certain feature. So if we conform to the question generator protocol, maybe in a quiz class later on, it basically reminds us, hey, you need to be able to generate questions for this quiz. And it's just a way to kind of compartmentalize and put features in a certain place where they need to go. So now that we have our protocol here, and we have the function generate random question that returns a question, we can go ahead and create a class for our quiz. Okay, so go ahead and type class quiz, and we're going to conform to the quiz generator protocol, like so. Okay, but it's going to throw an error at us. It's going to say, hey, we don't have that type, and that's because, oh, no wonder, that's because it's question generator. Okay, there we go, question generator, and it's going to throw an error at me saying that we have not yet conformed to question generator. That's because we are missing our blueprint instructions, generate random question. So inside of this class, I'm going to go ahead and I'm going to call generate random question, and you'll notice the error goes away because we have added all the functions that question generator says we need. We have not yet done anything with them, but we've at least called the function, so that's cool. But now we need to be able to generate a random question here. So let's go ahead and let's think. I want to basically choose a random question type, and then I'm going to basically pass in the values needed to generate a question, which is a type, a query, and an answer. So let's go ahead and let's generate a random number first. Okay, so let's just say let random numeral equals, and we're going to use arc for random uniform, and we're going to set an upper bounds of 4. Okay, now that's going to generate numbers between 0, 1, 2, and 3. Okay, 4 values, which is perfect when dealing with the index of something. So that's really cool. The issue, though, is that we're actually going to need this to be of type int and not type uint, which if you looked, you'll notice that arc for random uniform returns a uint32. So let's go ahead and type int, and we're going to pass our arc for random uniform function into that so that it is of type integer. Okay? So let's say this generates a number 2. Now, in our enums, we need to be able to allow number 2, which, remember, if we're dealing with an index, number 2 is really the third result. So that would be short answer, but an enum in and of itself does not have any kind of indexing system or a way to identify first, second, third, fourth. So what we're going to actually do is inside of our enum, we're going to create an array, and we're going to basically just we're going to pass in all of our types so that we can order them in some type of way. So we're going to go ahead and just type let types, and we're going to go ahead and pass in true, false, true, false, multiple choice, short answer, and essay. Okay? And this array is going to allow us to parse through, and I can pull out the index here at index 1, and I can pull out multiple choice. Okay, that's going to be how we identify the different types that we want. But we're getting an error here. Check it out. Enums may not contain stored properties. In order to circumvent this, we can create this as a static constant. Okay? Now, a static constant is basically going to allow this to exist for the entire life cycle of the app since it's static, and we're going to use that because we need to be able to access it all the time throughout when this code runs. Now, this is great for questions, but we're also going to need it for our answers as well. So I copied it and I'm pasting it down below. So we have a random number. Now we're going to need to use this number to basically pull out a random type from our random types array inside of our enumeration. So go ahead and type let random type equals question type. And what we're going to do is we're going to pull out our types array and we're going to pass in random numeral. Okay, now let's say that it was 2 or 3. Whatever it is, it's going to pull out a random one. Now, as it runs, you'll see, but we're getting an error here, and it's saying that we have not yet returned a question. That's because we have not yet returned a question. So let's keep building it. Remember, a question needs a type, a query, and an answer. So let's go ahead and type let random query equals random type, and we can pull out the raw value. Remember, if I pulled out multiple choice, the raw value is going to be the string here. That's my question. Okay, easy enough. So there we go. Let random answer equals, and where are we going to get the answer? We're going to get it from our answer type enumeration, and we can pull out the specific type using our array. Now, if I pulled out multiple choice here, I can use that same numeral value here to pull out the multiple choice answer. So let's go ahead and let's call answer type dot types, and I can pull out the right value using random numeral. Okay, that'll get the proper answer back for me. So now that we have those 3 values, we can create a question. So type let random question equals question, and we're going to instantiate it here with our random type, random query, and random answer. Okay? Now at the very end, we need to go ahead and just return our random question. That's not a question. Random question. There we go. Super cool. So as it goes through, the function will properly generate the value we need. But I'm noticing that it is giving us an issue here. It is saying we cannot convert answer type to expected argument string. So random answer is coming in, but we are just getting a random type here. We are not pulling out the raw value. Oh, that's right. So instead of that, at the very end here, I can go ahead and pull out the raw value for the item we pull out at that index. And now that error should go away. Really cool. So that's great. Now we have a quiz. We have conformed to the question generator protocol, and we have put in all the implementation code to generate a random question from our enumerations. So now if I create a quiz, check it out. I can type let quiz equals quiz. And then I can call quiz.generate random question, and watch what happens when I do that. It runs and it pulls out a question. Okay, super cool. Now it pulled out a question type of essay, and it pulled out an answer from our answers array. Now we have a type, a query, and an answer. That's so cool. So let's go ahead and let's actually print out what's happening here. And actually what I'm going to do is I'm going to put this inside of a constant, like so that I can actually pull this out. So let's just say question type, type, and I can pull out question, question dot type. Okay, and you'll see it'll print question type, multiple choice. Okay, then we're going to say query, and you know what, while we're at it, why don't we just go ahead and do /n to give us some space here. And for the query, we're going to pull out question.query, and then /n space, and answer, we can pull out question.answer. Oh, that's not an answer. Question.answer. So there we go. As it prints, we should get everything. Cool. Question type, short answer. Query, what is the capital of Oregon? Answer, Salem. Everything shows up exactly as it should. This is how powerful protocols are. It gives us the ability to basically create requirements that must be conformed to when using that protocol. And the cool thing is we can do a bunch of different things. Like let's say I wanted to create a new kind of protocol, maybe one that generates answers, and then you would have to do the questions, kind of like Jeopardy. So let's just go ahead and do protocol answer generator. And a protocol can actually inherit or conform to another kind of protocol. So that's really, really cool. Now, if you wanted to, you could use this as a way to add additional functionality. So func generate random answer. Okay, that could be my question, and I could create an answer type here. You know what, just for time, let's just go ahead and just create a class here of type answer, just so that it doesn't yell at me. And if I wanted to, I could create a class called Jeopardy, and I can conform to my answer generator, okay, which is really cool. But you'll see it's going to yell at me. It's going to say, hey, you have not yet conformed to answer generator. Now, I can go ahead and type generate random question or generate random answer, because I'm conforming to that protocol through my other protocol. So you can do it just like you can subclass classes. You can sort of subclass protocols as well, which is really neat. So let's go ahead and let's conform to generate random question. Whoops. So let's go ahead and let's conform to generate random answer. And you'll see we're still not getting conformance. And why is that? Because we're not generating a random question as well. In order to conform, we have to meet the requirements of both generate random answer and generate random question. Okay? That's just something we need to do. That's part of the power of protocols. You can create a bunch of nested protocols just like that. It's pretty cool. Now, of course, we're not returning anything here, so it's going to yell at us, but I hope you can see how helpful protocols can be in at least some small ways. And in the next couple videos, we're going to build an app that allows you to pass values back and forth between view controllers using protocols as a way to delegate information. It's called the delegate method, and it's something that's commonly talked about with protocols. We can use protocols to delegate information to other classes, because remember, a protocol itself does not contain any implementation. We implement it on a view controller. And so using conformance between two view controllers, we can use protocols as a way to delegate that information. It's really, really cool. So let's go ahead and let's head over to the next video and let's build it out.